Greetings. Welcome to Week 3 of GIS 4630, Public Domain Data for GIS. Joseph Kursky here with you now to talk about what we will do in Week 3 of our course. Now this week you will have the opportunity to consider raster data, representation, types, sources, and characteristics. You will also consider location privacy issues, which will run throughout the course as well. You will use data from the National Renewable Energy Laboratory, or NREL. Now this week specifically, you will be reflecting on your readings and the short hands-on activity I will describe in a moment. Please read Chapter 3 in your textbook. This will provide context and information about raster data and privacy issues. And please begin Lab 2, which I will describe in a moment. Please read the slides Public Domain Data Overview and a GIS Overview in the Files section of our course, if you've not already done so. So, what we'll do is we'll grab some data from the NREL National Renewable Energy Lab. You'll basically download some high-resolution wind data for the state of your choice. And I want you to reflect on a couple of things. First of all, what was the most significant thing you learned about raster data from your Chapter 3 reading? Number 2, what was the most significant thing you learned in Chapter 3 about data privacy issues related to GIS and spatial information? And number 3, describe the high-level, high-resolution wind data that you downloaded from the NREL site, indicating the data model. Was it raster or vector? What kind of file type was it stored in? What map projection was it in? How easy was it to download from the NREL site and start using it? And then, more importantly, describing the pattern of the wind speed in the state that you are analyzing. You know, what are a few reasons for the wind pattern or the wind speed distribution to have that it does? Is it topography? Is it something else? Is it prevailing winds, the intersection of air masses across that state? You know, what is the situation there? What other layers would you like to have data-wise if you were really going to use the NREL data to recommend specific locations for a wind turbine farm in the state that you are analyzing? What agencies or organizations might have these specific data sets? Now, here's a couple of notes on Lab 2. In Lab 2, what you're going to do is select the most suitable locations for tea cultivation in Kenya using GIS. So you're going to be using data that is a variety of different layer types, different data models, and what you're going to do is, again, to look at spatial patterns, use spatial thinking, use spatial analysis tools to arrive at a set of conclusions. Now, tea is an important world cash crop, and Kenya is one of the leading tea producers in the world. It's fourth in the world after China, India, and Sri Lanka. Now, farmers in Kenya have been producing tea since 1903. So even with such high production levels, more than 60% of the tea in Kenya is grown on small or family-run farms, organized and managed by the Kenya Tea Development Agency, or KTDA. So the problem I give to you in this particular lab is hearing about your GIS skills. The Kenya Tea Development Company, say, has hired you to select additional lands that might be suitable for expanding tea cultivation. So according to the KTDA, tea is grown on tropical red loam mixed with volcanic soils found in high-altitude areas of Kenya. It does well between 1,500 and 2,250 meters above sea level, and the rainfall range is about 1,200 to 2,500 millimeters annually with long sunny intervals. The situation, though, is that less than 8% of the land in Kenya is used for crop and feed production, and less than 20% is suitable for cultivation at all. And of that 20%, only 12% is classified as high yield. So what you're going to do is you're going to select the lands that are potential tea cultivation sites with the following characteristics. It's got to be on moderately high ground. It's got to be on land with this certain range of annual rainfall. It can be within 500 meters of an urban area. It can't be in a wetland because of unsuitable growing conditions. And also, it cannot be within 100 meters of a river due to potential for flooding and to protect the riparian zone. It can't be within 250 meters of a major town. It cannot be in a protected area. It cannot be in a water body, obviously, because of unsuitable growing conditions there. It must be within 5 kilometers of a major road to reduce transport costs, and it must be on agricultural land partly or wholly designated as herbaceous crop. So you're going to join some data, you're going to sort it, you're going to query it, you're going to download it, you're going to project it, you're going to do some other geoprocessing operations, you're going to symbolize, classify, make a decision in the GIS environment. And so it's got several work packages, each made up of multiple steps. But keep in mind the end goal is not to necessarily memorize these specific GIS operations, but it's to use GIS effectively to make a decision and to use public domain data to do it, assessing the quality, scale, and so on, completeness of the attributes and other characteristics of that data as you're doing so. Keeping in mind, is this data the most suitable data for my analysis? Would I like to have other additional layers as well as these? If so, how would I obtain them? Who would produce them? And so on. So welcome to week 3. I hope you enjoy it, and we'll see you online.